Okay, factor this. 7x to the power of 5 minus 2x to the power of 4 plus 8x cubed minus 2x plus 5. Okay, by the the coefficients are integers, but the coefficient of this one is not equal to 1. So by the method, we should multiply and divide the whole polynomial by 7 to the power of 4. Okay, and the 5 here also got multiplied by this, and then we should try and substitute the divisors of this number, which is a crazy number. Okay, but in order to solve that, we got a theorem which is a general form of the theorem I mentioned before, in which the coefficient of the term with the biggest degree, it should be 1. Okay, and this theorem, the general form theorem, called the rational root theorem, which says that for a polynomial with integer coefficients, the possible rational roots of it, rational roots which are in this form p over q, in which p and q are integers and relatively prime, which means that, for instance, 6 over 4 equals to 3 over 2. But here, 6 and 4 are not relatively prime, because the greatest common factor of those are not equal to 1. But these two are relatively prime. Okay. The theorem says that the possible rational roots of such a polynomial, which is like this, for that we have the denominator, or p, is a divisor of the constant number 5 here, and the denominator are a divisor of the coefficient of the term with the biggest degree, here 7. So p could be a divisor of 5, positive and negative. What are the divisors of 5? Positive and negative 1 and positive and negative 5. And the divisors of 7, positive and negative 1 and positive and negative 7. Okay, so the possible rational roots, what are the possible rational roots? Positive and negative 1 over positive and negative 1, positive and negative 1, positive and negative 5 over this, a positive and negative 5, positive and negative 1 over this, positive and negative 1 over 7, and this over this, positive and negative 5 over 7. Okay, so we should substitute these 8 numbers into x here instead of substituting the divisors, positive and negative divisors of this crazy number. Okay, I'm not gonna do that, but you could as a practice do it. Okay.